In this part of trigonometry, we are going to be looking at graphs, and specifically graphs of three of the trigonometric functions that we have discussed previously. They are the sine function, the cosine function, and the tangent function. And what we want to be able to do is definitely to be able to sketch these three graphs, and we also want to be able to sketch the transformed versions of the three graphs. So let's take a look at the sine and the cosine graph first. What you will notice about the shapes of the graph is that they look like wave, right? Okay, they look like wave, but let's look at the details of this wavy graph that we have here on the board. Let's look at the sine function first. It starts from the origin and it ends at 360 degrees. And if you were to be looking at the graph in terms of radians, then you will end at 2 pi radians, okay? We have discussed this before. 360 degrees is equivalent to 2 pi radians. And what you also realize for the sine graph is that it starts from the origin and it will go to the maximum point, comes back to the x-axis, go to the minimum point and ends at the x-axis again. And this actually occurs in a fixed interval. And the interval is a quarter of 360 degrees or a quarter of 2 pi. For example, if I were to go for degrees, 360 degrees divided by 4, a quarter of 360 degrees is 90. So for 90, it is going to experience a maximum point. Another 90, it comes back to the x-axis. Another 90, it experiences a minimum point. And for the last 90, it goes back to the x-axis again. This happens also for the cosine graph. It starts from the origin and it ends at either 360 degrees if you are going for degrees, but if you are going for radians, it will end at 2 pi. And it is going to be divided into 4 equal intervals. And 360 degrees divided by 4, 90. So it started off at the origin where it is experiencing a maximum point. Then it goes to the x-axis in the first 90. For the next 90, it will go for, you experience a minimum point. And the next 90, it will go back to the x-axis. And for the last 90, where it reaches 360, it will go back to a maximum point. These are features that we usually will also discuss for any other graphs, right? You know, like maximum point, minimum point, the places where the graph cuts the x or y axis. But for trigonometric functions, we also want to talk about 3 more key features. And let me show you what are the 3 more key features. They will be the period, the amplitude, and the range. What is the period? The period is the smallest size of interval between repetitions. What do I mean by repetitions? Because for what we are seeing here, okay, let's say we look at the sine function. What we are seeing here is not the full sine function, not the graph of the full sine function. Let me now show you the full graph of the sine function. I'm going to make use of my graphing calculator. I'm going to attempt to plot the graph of sine x. Let's take a look at the graph. The graph looks like this. Okay? If you were to compare this to what I have on the calculator, you will notice that this portion of the graph is the same as this portion here. From the origin to the maximum, back to the x-axis, to the minimum, then back to the x-axis. It is this portion here that I've sketched on the board. But the full version goes all the way to the left and it goes all the way to the right. And what you will notice is that the shape actually repeats itself. Because for a sine function, the same goes for the other 2 functions, they are periodic in nature. That means after every fixed period, the graph actually repeats exactly and then repeats and repeats. So the graph will repeat to the right and the graph will repeat to the left. So what is the period of the sine function? The period is the smallest size of the interval between repetition. And for the sine function, the smallest interval is 360 degrees or 2 pi, which is what I've quoted here, the period. Okay, we need to memorize this. So what is the period of the sine function? 2 pi or 360 degrees. What is the amplitude of the sine function? The amplitude is defined as the y maximum minus away the y minimum divided by 2. What is the y maximum? 1. What is the y minimum? Minus 1. So what is 1 minus 1? 2. Divided by 2 is 1. So the amplitude is actually this here. Okay, the amplitude is actually this here, which is the way that it goes up and down, up and down. This is the average, so 1, 1. So the amplitude of a sine function is 1. And what is the range of the sine function? Okay, when I talk about the range of the sine function, this word range is very commonly used. But when it comes to a function, when we talk about range of the function, it actually specifically meant the y coordinates of the graph. So what is the range? It is the full set of values of the y coordinates on our graph. So what is the full set of values of the y coordinate? If you were to look at this graph, anyway, it is going to be repeating to the right, it's going to be repeating to the left, but because it is going to be replicating this, all the y coordinates are going to be between -1 and 1, and this will give us the range of the sine function. So we have it here, sine x is always going to be between -1 and 1. So y is also going to be between -1 and 1. I mean, you can press this into the calculator to do a quick check. Regardless of whether you are in the degrees mode or in the radians mode, whenever you press an angle into the sine function, you realize that the result will never go beyond -1 and 1, which also implies that regardless of the angle that I input into the sine function, I will never get, for example, sine x is equal to 2. Okay, this will never happen because the result of sine x will always be between -1 and 1. Actually, this is very similar for the cosine graph. The period is also going to be 2 pi. Or 360 degrees, which means that after every 2 pi or 360 degrees, the graph will just repeat itself again towards the right, repeat itself again towards the left. The period is 2 pi, the period is 360 degrees, the amplitude is 1. 1 minus 1 is 2, 2 divided by 2 is 1. So the amplitude is this, it is 1. What is the range? The range is also from -1 to 1. So for the period, amplitude and range-wise, for sine and cosine, they are actually exactly the same. Now let's take a look at the tangent graph. The tangent graph has a shape that is like this, and it actually bears 2 vertical asymptotes. But there are some students, when they try to replicate this, they tend to draw it wrongly, especially here. Okay, so I just want to make a point about how we should be sketching this part of the graph. So let's say we have a vertical asymptote, let's say we have another vertical asymptote here. What some students did which was wrong is something that is like this. Okay, here. Then they try to draw this part of the graph this way, here. Okay, they are trying to draw this part where the curve becomes too horizontal. It is not going to become horizontal because here there is actually a slope. So what you need to do when it comes to this part, you need to draw it such that there is this little slope. Okay, then it will be correct. So if you have drawn the correct version and if you have put in the 2 vertical asymptotes and they happen at -90 degrees or -pi/2, -pi/2 is the same as -90 degrees, and the other vertical asymptote is at pi/2, and the graph will start all the way below, then you will make a little curve, and the curve should be like this, then go all the way to the top. And for the tangent graph, it is also periodic in nature. So the period is pi, or the period is 180 degrees. So this actually gives us an interval where the repetition will occur towards the right and towards the left. Let me show you on my graphing calculator the tangent graph. So now let me draw another graph for us, the tangent x graph. So let's take a look at what is tangent x. Let me clear away this. So here, let me delete away this. Okay, close bracket. The tangent graph looks like this, okay? It is taking this, and if we were to just duplicate it towards the left, duplicate to the right, then you will get the full tangent graph. And the period is going to be from here to here. It is going to be pi, or it's going to be 180 degrees. What about the amplitude? The amplitude is taking the maximum minus the minimum divided by 2. And what is the maximum? It is infinity. What is the minimum? It is minus infinity. So for a tangent graph, we don't really talk about the amplitude, because we can just see that the amplitude is undefined since it's going to be so huge anyway. But we can talk about the range, because for the range, it is the full set of values of y that we can see from the graph. So what is the full set of values of y? It is going to go all the way from negative infinity to positive infinity, which means that y actually take the full set of values of real numbers. That is why what I wrote here is that the range of a tangent is going to be just all real numbers. So it is possible to get, for example, tangent x is equal to 4 point something. Unlike the sine and cosine, they will always be between -1 and 1. But for tangent, it can go at a high number, it can also go for a very negative number. So if you can just put in a bit more effort to sketch this graph a few times, I believe they are going to be easy graph to be sketching in the exam because we can already memorize them. But we are usually going to be tested on sketching variations of this graph, the transformed versions of the graph. So let us take a look at the transformed versions of graph and how can we sketch them. And what do I mean by the transformed versions of the graph? That means the graphs are going to be inspired by the three graphs here, but they are going to be changed in terms of the expression. Like for example, A sine A sine of bx plus c. So an example is this. Okay, and how I'm going to try to discuss about the transformed graph with you is let's just try to sketch some graphs together, and along the way we are going to carry out transformations, which I'm going to be making use of this table that I have drafted out here. I think this table is going to be very useful. It describes to us how the transformation is going to be taking place, and we can just follow the transformation, and it describes to us what are the new features that we will be expecting. Like for example, a transformation can sometimes cause the period to change, and this will give us the new period according to the table. So let us start by taking a look at this function here. Okay, let's try to sketch the graph of y is equal to sine 2x. Let me clear the board first. Okay, let's try to sketch this. The graph of y is equal to sine 2x plus 3. And what I'm going to do is I'm going to break up my procedure into a few different steps. Okay, I'm not going to draw this graph directly. What I'm going to do is I'm going to draw a version of this graph first, and I'm going to draw the graph of y is equal to sine 2x first. So let's draw this graph. The graph of y is going to sine 2x, and obviously this graph is going to be inspired by the graph of y is equal to sine x, except that x is replaced by 2x. Let's refer to the table. So it is this b that we are going to be discussing, and in this case b is 2, and 2 is a positive number, so we are going to be looking at this part of the table. Okay, if b is a negative number, we are definitely going to be looking at this part of the table. Same goes for a and c. So let's just follow the condition for the different parts of the table, and we will go for the instruction that is according to this part. So b is bigger than 0. That means that the transformed graph will be scaled by a factor of 1 over 2 parallel to the x-axis. It's going to be scaled by 1 over 2 parallel to the x-axis, which means that the transformed graph is going to be compressed by 2 times. It's going to be scaled by 1 over 2 parallel to the x-axis. So I'm going to take this graph, and we're going to draw the graph of this by scaling it by 1 over 2 parallel to the x-axis. So my graph is going to look something that is like this. Here, this graph is going to be scaled by 1 over 2 parallel to the x-axis. So this will be 0, and 90, this will become 45. 180, this will become, 180 will become 90. Then 270 will become this point here, the minimum point, 135. And 360 will become, dividing by 2, it is going to become 180. And this will not change. It is still going to be at -1, it's still going to be at 1. So what I've actually decided to do is, since we are learning radians for the very first time in this chapter, so probably not every one of us are already that well adapted to the usage of radians. So maybe I can start by drawing a graph that is focused on using degrees, and maybe let's do that for 2 of the graphs. Then we will draw the last 2 graphs using radians. Okay, so I'm focusing on degrees, so 360 divided by 2 gives us 180. The same goes for these 3 other intervals. So we have this. And this will represent for us the graph of y is equal to sine 2x. And then after that, I'm going to try to manage this plus 3. So I'm going to then sketch the graph of y is equal to sine 2x plus 3. Plus 3, according to the table, is this plus c. And c that we are looking at here is a positive number. So it is going to be a translation of 3 upwards. Okay, a translation of 3 upwards. So we're going to take this graph and we're going to translate it by 3 units up. And okay, I think when we are trying to transform this entire graph upwards, sometimes we tend to be a bit messy when we are trying to sketch this. So I have a suggestion, okay? Instead of just directly transforming the entire graph, maybe what we can do is we pick a few points and we try to transform those few points first. Then after that, we join the points together using our smooth curve. And the points that I'm going to be using will be this point here, this point here, this point here, here, and here. Let's discuss about how these few points are going to be like on this graph of y is equal to sine 2x plus 3. So let me sketch this graph. This is my final graph, so I'm going to sketch it a little bit bigger. So the x-axis is here, the y-axis is here. First of all, this middle line here, okay, it is going to be translated by 3 units. And I think this middle line here, y is equal to 0, is good to focus on its transformation first because everything is going to go about this middle line. So I'm going to transform that up by 3 units, which will give me, let's say, a line here. And this horizontal line is going to be at 3, okay, because y is equal to 0, it's going to go up. It's going to become a line y is equal to 3. And how about this point here? This point here will now be here, right? From 0, 0, it will become 0, 3. And how about this point? This point from 45, 1, it will become 45, 1 plus 3, 4. So let's say it is going to be a point that is, for example, here. Okay, let's say this is 4, which means that I will have a point. For example, this is 45 and 45, 4. So this point here will be the transform point for this. Next, I'm going to go for this 90. So it is going to be at 90, 90, 0. It will become 93 because this point is going to go upwards. So it will be 93. So let's say we have this 90 and 3. So it's going to be here. Then after that, this point, the x coordinate of this point is 1, 3, 5, and the y coordinate is -1. So -1 will be added 3 to it to be transformed, to be translated up by 3 units. So -1 plus 3 gives me 2. So I'll need a 2 here. So I'm going to mark down here 2, and it is going to be somewhere here. Okay, let's say it is this point here. So this happens at 1, 3, 5. And the final point is going to be this 180. So it's going to be 180, 0. 180, 0 is here. So it's going to become 183. So it's going to be a point that is, let's say, here. Okay. So we have 180. Then we're going to join the points together by using a smooth curve. So we are going to be expecting this. Then coming back down to here. Then to here. Then back to here. This will give us the graph of y is equal to sine 2x plus 3 for one period from 0 to 180 degrees. But it really depends on the question because in the exam, almost all the time they will tell you from what is the range of values of x that they will want you to be sketching. So for example, if they were to ask you, can you try to sketch this graph such that x is going to be between 0 to 360 degrees? If this were to be actually given to you by the question, which most likely it will be given, then what I would suggest that you do is you draw for one period first, like what we have here, and then you extend to the left or extend to the right to fill up the space that is given or to cut off according to the range that is given to you, the set of values of x that is given to you. So if they were to ask for 0 to 360, I've already drawn one period which is only from 0 to 180, then I'm going to add one more part to it. Okay, I'm going to just roughly sketch it to fulfill the shape of the entire graph that is asked by the question. So I'll sketch all the way until 360. And of course, okay, you should fill in the coordinates of this point, the coordinates of this point, and the coordinates of this point. Okay, you just need to add 45, 45, 45, and to the final one, which is going to give you the 360. So, yep, this is the graph of y is equal to sine 2x plus 3. It is a transformed graph of the graph of y is equal to sine x. Let's take a look at the other one. The graph of y is equal to 5 cosine 4x minus 1. Oh, but before that, okay, let's talk about the features. Okay, we have forgotten about the features, the 3 features that we have discussed previously. So, what is the new amplitude? The amplitude has not changed. Okay, the amplitude remains at 1. Okay, we can see it from here, right? Because you will realize that for the amplitude to change, this A is going to be the key. So the coefficient of sine or the coefficient of cosine is going to be the key. It will be the original amplitude multiplied by A. So in this case here, it is 1. So it is not going to change, right? It is still going to be 1 after the transformation. So it's going to be 1 times 1, which gives me 1 as the amplitude for this. As for the period, the new period is going to be affected by B. So in this case, it's going to be affected by 2. Since 2 is going to be scaling everything by 1 over 2, parallel to the x-axis. So everything is going to be compressed. The original period is 2 pi. It is going to be compressed. Sorry, we are in degrees. So the original period is 360. It is going to be compressed. So it's going to become a new period of 180, which is the formula that I gave you here. The new period is going to be the original period divided by B. So we have used this, and how about the maximum and minimum y value? What is the new range of the function? I think that for the new range of the function is easier to evaluate them by imagining the transform graph. So we can imagine that for this graph, it's going to be translated by 3 units upwards. So the original maximum point is 1. The new maximum point will be 1 plus 3, which gives us 4. But the minimum was minus 1, and the new one will be minus 1 plus 3. So it's going to give us a 2. So for the new range, it's going to be from 2 to 4, like what we have written down here. Okay, the minimum is 2, the maximum is 4. And after a while, you'll realize that regardless of whether you physically sketch out the graph, okay, most likely for most of you, you will be able to predict all these values by just imagining the transformation of the graph, or of course to make use of the formulas that I've given to you here. Okay, now we are ready. Now let's make use of what we have just learned, the experience that we have just gathered, to try do the next one. Y is equal to 5 cosine 4x minus 1. So we have a y is equal to 5 cosine 4x minus 1. And let's go for degrees again. If you were to look at this, can we first predict what is the amplitude? The amplitude will be the original amplitude, which is 1, multiplied by 5. Okay, I'm using what I have here. Okay, A is going to affect the amplitude. In this case, A is 5. So what is the new amplitude? 5. What is going to be the new period? The new period is going to be the original period divided by B. In this case, B is 4. So it is going to be the original period, 360 degrees, divided by 4. So the new period is going to be equal to 90. And for the maximum and minimum, let's try to imagine the graph. And based on the graph, we are going to try to add or minus based on how the graph is going to be translated up or downwards. So if the amplitude is 5, that means it's going to be from minus 5 to 5. And then it is going to have this minus 1 here. Minus 1 here will cause the graph to be translated by, okay, this is a negative number, so I'm going to be using this. Okay, so it's going to be translated by minus C, which means that it's going to be translated by minus 1. Our aim is just to make it positive. So minus 1 is positive 1, so it's going to be translated by 1 unit downwards. So the original maximum and minimum was at minus 1 and 5, so it's going to be translated downward by 1 unit, so it's going to be at minus 6 and 4, which is what we have here, minus 6 and 4. Let's try to sketch this graph, okay? And again, I'm going to sketch this graph in a few parts. I'm going to sketch it based on this first. Y is equal to 5 cosine 4x. I'm going to leave out this minus 1 first, okay? So to sketch this, it's going to be from here. This is the x-axis, this is the y-axis. I know this is going to have an amplitude of 5. So instead of it's the cosine graph. So instead of 1, it is going to be starting at 5. It's going to go all the way until minus 5 as the minimum point. And the original amplitude, the original period is 360. Dividing this by 4 will give us the new period for this graph. 360 divided by 4 is 90. So I know that my graph is going to go all the way until 90. And this is going to be divided into 4 equal parts. So let me divide it first. So 90 divided by 4 is 22.5. So this here is equal to 22.5. This over here is going to be 45, and then plus another 22.5, this will be 67.5. And now I'm ready to duplicate this shape here. I'm going to start from here. Then you'll go down to here. Then you'll go to this point here. So I'm going to put a little dot just to facilitate me to join the points. If I'm not very confident about drawing them, then this is going to be here. Here is going to be at this highest possible point here, let's say. So it's going to be from here, and then you will join to the minimum point here. Then you will come back to this point, and our end of here. So this will be the graph of y is equal to 5 cosine 4x. And then minus 1. According to what we have, minus 1 is going to cause the graph to be translated by 1 unit down. Okay, like what we have discussed. It's going to be translated by 1 unit down. So we're going to be expecting ourselves to be shifting this down by 1 unit. So let me draw the final graph. The graph will be y is equal to 5 cosine 4x minus 1. So just like what we did in the previous graph, I'm going to draw that middle line first. Okay, I always find that very, very useful. So the middle line is going to be this. This is at minus 1. And then I'm going to draw the points. And the points that I'm going to be focusing on will be this point here, this point here, this point, this point, and this point. So this point here is going to be shifted down by 1 unit. So I will be getting a 4. So 1, 2, 3. So let's say 4 is here. So it will be here. It will be here. Then this point here will be shifted down by 1 unit. So it will be here. So let me draw a little line down from here. So let's say here. Okay, it's going to be shifted down to here. This is going to be at 22.5. And then this is going to be shifted down also all the way until minus 6, right? Minus 5 shifted down by 1 unit, it will be at minus 6. So 1, 2, 3. So let's say it is going to be, let's say here. Okay, it is going to be at minus 6. So it will be at 45. So let's say here is 45. And I'm going to go all the way down to here. Okay, it will be at this point. And then this here, 67.5. So, okay, 67.5 is, let's say here, 67.5 is going to be shifted down by 1 unit. I'm going to get this point. And then 90, this point is going to be shifted down by 1 unit. So at 90, so let's say 90 is here. At 90, it is going to be shifted down by 1 unit. You'll go back to 4. So let's say it is going to end at a point that is here. Okay, and now I'm ready to sketch this graph by joining this together, joining the points together. So from here, it will be like this, coming all the way down to this point here, and coming down to this point here, then coming back to this, going back up to here, and then finally to this. So coming back to join it here gives me the graph of y is equal to 5 cosine 4x minus 1. Let's proceed to the next one. And this time for the last 2 graphs, let's go for radians. So we are going to be sketching the graph of y is equal to minus 4 sine x over 3 minus 2. So what is the new period? Okay, this is a little bit tricky because the b in this case is 1 over 3. Okay, the b is 1 over 3. Which means that for the new period, it is going to be the original period of the sine, because this is sine, the original period of the sine, which is 2 pi, divided by 1 over 3. Okay, some students will just see, oh, this is 1 over 3. So they will just take 2 pi divided by 3. Okay, and that is wrong. It is going to be 2 pi divided by 1 over 3, like what I've written down here. Okay, so the period is going to be 2 pi divided by 1 over 3, and the new period is 6 pi. So please take note, it can be tricky to some of us, so we want to make sure that we don't commit this mistake during the exam. If you were to be in degrees, it is the same. It is going to be 360 degrees, which was the original period of the sine graph, divided by 1 over 3, which gives us 1080 degree as the new period. How about the amplitude? The amplitude is going to be the coefficient here. We can ignore the negative. And the amplitude will be the original amplitude, which is 1, multiply by 4. So the new amplitude is 4. And the whole graph is going to be translated by 2 units in the negative y direction. It's going to be translated by 2 units downwards. So for the original graph, the maximum and minimum is going to be at plus 4 and minus 4. So it's going to be translated down by 2 units. So plus 4 becomes 2, minus 4 becomes minus 6. It will be from minus 6 to 2. Let's try to sketch this graph, and just like how we have done in the previous 2 graphs, I'm going to sketch the graph of y is equal to minus 4 sine x over 3 first. But unlike the previous 2 graphs, there is the negative here, and this negative has to be managed. So what I'm going to do is I'm going to ignore this negative first, which means that I'm going to break up this graph into a further, I'm going to split it into a further, one more graph. Okay, so that means I'm going to be drawing this graph. Then I will draw minus 4 sine x over 3. Then I will draw y is equal to minus 4 sine x over 3 minus 2. So instead of just 2 graphs that we have sketched in the previous 2 examples, I'm going to now sketch 3 graphs in order for me to derive at my final graph. Let's look at this first. So for this graph, the y-axis, the x-axis, okay, so let's say I have this. For this graph, the period is going to be 6 pi. 2 pi divided by 1 over 3, it is 6 pi. So it's going to be from 0 all the way until 6 pi. And I'm going to divide this into 4 parts. So it is going to be, the middle here is going to be at 3 pi. Which means that this is going to be at 3 pi over 2. And this here is going to be at 9 pi over 2. And the amplitude is 4. So from 1, it will now become 4 and minus 4. So you'll start here, then you'll go up here, then you'll come back down here, and you will go here, and then you'll end up here. So from here, it is going to go to this point, and then you will come to here, and you will come down to this point here, and then you will come back up to this. This will give me the graph of y is equal to 4 sine x over 3. So this was what we have discussed, but what we didn't discuss in the previous 2 examples is, what if a happened to be negative? If a happened to be negative, we need to do one more thing, which is to reflect it about the x-axis. It is going to be reflected about the x-axis. So let's try to draw this graph. Everything remains the same except that it is going to be reflected according to the instruction that I have here when a is a negative number. So my new graph is going to look something that is like this. So the x-axis, the y-axis is going to be from 0 all the way until 6 pi. This is not going to change. And here it is going to be 3 pi. Here is going to be equal to 3 pi over 2, and here will still be 9 pi over 2. The maximum is still going to be at 4. The minimum is also still going to be at minus 4. So this point, it is still going to remain here. But this point is going to be reflected. So I'm going to get a point that is here instead. This point will remain. And this point is going to be reflected. So I'm going to get a point that is, let's say, here. And this point will remain here. So my graph is going to be like this, going all the way to the minimum point here, coming back up here, because it is reflected about the x-axis. So I'm going to be getting a shape that is like this. Okay, this graph being reflected about the x-axis. And then finally, minus 2 will cause this graph to be translated by 2 units downwards. So my final graph is going to be like this. The y-axis, the x-axis. I'm going to translate the middle line down first, and that will be at minus 2. Okay, so this is at minus 2. So this point will be translated downwards. It's going to be here. And this point will be translated downwards. So let's say here is where I have the 3 pi over 2. It is going to be somewhere here, translated downwards by 2 units. So it is going to be at minus 6. So it's going to be a point that is here. Then this 3 pi is going to be translated downwards. So here, let's say it is 3 pi translated downwards by 2 units, give me a point that is here. Then 9 pi over 2, this point is going to be translated downwards. I'm going to get a point that is, let's say, here at 2. So at 9 pi over 2. I'm going to be getting a point that is, let's say, here. And finally, this is also going to be translated by 2 units. So my final part is going to be at here, 6 pi. Here is where the translated point of this is going to be. And now I'm ready to draw my final graph. I will just connect all these points together to form for myself a smooth curve. And this forms for me my final graph of y is equal to minus 4 sine x over 3 minus 2. Let's look at our last example, and it is a tangent graph. We have not sketched a tangent graph so far, so will it be interesting or will it feel very different? Let's find out. So this final graph that we're going to be sketching is this here. Okay, the graph of y is equal to 6 tangent x over 2 plus 1. And I'm going to sketch the graph of y is equal to 6 tangent x over 2 first. So for this graph, what is the amplitude? So for tangent, we don't really talk about amplitude. So this 6 is not going to change anything, but we can change the period, because what is b in this case? B is 1 over 2. So for the new period, it is going to be the original period divided by 1 over 2. The original period is pi. So pi divided by 1 over 2. Okay, again, this is the same trick as what we saw here. So it is not pi divided by 2, but pi divided by 1 over 2, which gives us 2 pi. So that is going to form for us the new period. And of course, if it is in degrees, then it's going to be 360 degrees divided by half, which gives us 720 as the new period. And for the maximum and minimum, it is still going to be at plus or minus infinity, so that is not going to change. So it seems like tangent is easier to draw. Let's see whether it is really so. I'm going to sketch this graph, the y-axis, the x-axis, and I'm going to sketch in the 2 vertical asymptotes first. So the vertical asymptote is going to be scaled by 1 over 2. So it's going to be scaled by 2, like what we have written down here. It's going to be scaled by 1 over 2. So it is actually going to be expanded by 2 times, 1 over 2. So it's going to be scaled by 2 parallel to the x-axis. So the 2 vertical asymptote will now be at minus pi and pi. And the period is, like what we have discussed, is going to be 2 pi. So from minus pi to pi, the period is 2 pi. And my graph is going to be like this. And I want to make sure that this part is not too horizontal. So it is going to be this, here, and here. Okay, this is the graph. And plus 1 is going to cause the entire graph to be translated by 1 unit upwards. So my graph is going to be like this. Y is equal to 6 tangent x over 2 plus 1 will look like this. This is the y-axis. This is the x-axis. The 2 vertical asymptotes remain the same. So it is still going to be at minus pi and pi. And this point here, this point at the origin, is going to be shifted by 1 unit upwards. So it's going to become here, let's say. So here is 1. So my graph is going to look like this. It will pass through this point and it will tend towards the vertical asymptote. So in fact, I think the tangent graph is easier to sketch. And these are the examples that I have, and I hope that you have learned something for us so that we can sketch the graph of the trigonometric functions. And once you're ready with this, it is time to proceed to the next part of the chapter, and I'll see you there.